Extending the idea of permutations, we have something else called as combinations. The only difference between permutations and combinations is that with combinations, order does not matter. What do I mean by that? Well, whether it is AB or BA, they mean the same. Suppose you have a basket filled with letters A, B, C, D, all the way up to Z, and you pick 2 letters out. Whether you pick it as AB or BA, it is the same thing. So when you pick those 2 letters out, it doesn't matter what order they are in. So in this case, it is not a permutation, rather it is a combination. So let's make this interesting. Suppose we have 4 letters A, B, C, D, and we'd like to choose two letters. We're not placing in order. So in this scenario, I could pick AB, I could pick AC, I could pick AD, I'd have BC, BD, and CD. That's it. I have 6 possible ways in this scenario. Now that is a combination because order does not matter. If you recall, instead of doing this, we want to do a permutation, then I would have written it as AB, AC, AD, BA, CA, DA, BC, BD, CD, I have CB, DB, and DC, which would result in 12 possible ways. So these are permutations, and on the left hand side what we have is combinations. So if we want to do permutations, then we know that we make use of NPR, but if we want to do combinations, we just do NCR instead. The formula for NCR is n factorial over r factorial times n minus r factorial. If you observe closely, all of that is nothing but NPR, because we know NPR is n factorial over n minus r factorial. So NCR is nothing but NPR over r factorial. In other words, we're just getting rid of the order, the number of ways in which some outcomes could be the same in a reverse order. For instance, we have to get rid of AB and BA because they mean the same thing. So that division by r factorial would actually take care of getting rid of those extra outcomes in the case of combinations. So that being said, if we want to find 4C2 in our problem, I could have done it this way: 4 factorial over 2 factorial times 4 minus 2 factorial, which would give me 4 times 3 times 2 times 1 divided by 1 times 2 times 4 minus 2 factorial is 2 factorial, so it's 2 times 1 again, could cancel these out, and I'd end up getting 6. This is nothing but the same answer that I had when I wrote things out. So is that a better way? Is that an easier way to do this? When n is large and r is also large, for instance, suppose you have 15 different items and you'd like to choose 3 of them. In other words, you want to find 15, choose 3. You can do it this way, but a better approach is to use a calculator. Sorry about the line, it just happened there. Using a calculator, we could see that 15C3 is nothing but 15 math PRB 3 and 3. 15C3 is what we have, and if you press that, you'd find it to be 455. So it's 455 ways. The next time you'd want to do combinations, I would highly recommend that you use a calculator.